In this video, I'm going to show you how to do the same system as previous, but this time we're going to do substitution instead of elimination. There really is no preference which one is better. Personally, I like elimination, but some people like to substitute better, so we'll show both. As before, we're going to label these A, B, and C, and then we're going to pick two equations. So this time, I think I'll pick B and C. And basically, I want to isolate the same letter in both equations. So it looks like Y will be the easiest to isolate. So I'm just going to simply move that 2x and that 2z over. And then I want to do the same thing for equation C. So I'm going to need to lose the 4x, lose the z, and divide everything by 3. So I should end up getting negative 4/3 x minus 1/3 z and 16 over 3. So once I do this part, I want to set these answers equal to each other. So basically, I'm taking this solution and I'm substituting all of that in for y down here. So we'll have negative 2x, positive 2z, positive 9, and that should equal all of this, negative 4/3 x minus 1/3 z. And then what we learned the other day was you can either work with the fractions or you can eliminate them. So I'm going to choose to eliminate all of my fractions by multiplying every term by 3. So now I'll have negative 6x, a positive 6z, and a positive 27 on the left. On the right, I'll just have negative 4x, negative z, and positive 16. And then you can just go through. I like to get my x's and z's on the same side just to be consistent, so we'll just do that quick. Add 4x, you get negative 2x. Add z, you get 7z. Subtract 17, so 16, or excuse me, subtract 27, so 16 minus 27 should be negative 11. And then as before, I like to draw a box around my simplified solution. And then we'll come back to that. So we're going to pick two other equations. This time I think I'll pick A and C. So the good news is the C equation, that's already solved for in terms of y. So you do want to solve for the same letter as you did up here. So we're going to have to isolate y. It's already done for C, so I'm just going to write down my answer. So equation C, y was negative 4/3 x minus 1/3 z plus 16/3. So again, that was for equation C. And then for equation A, if I want to get y isolated, I'm going to need to lose the x, lose the 3z, and then divide everything by 2. So it looks like I'll have a negative 1/2 x. And again, I'm just doing this in my head. A positive 3/2 z, and a positive 11/2. And then what I'm going to do is set these two guys equal to each other. So negative 4/3 x minus 1/3 z plus 16/3 all equals negative 1/2 x, 3/2 z, and 11/2. So this time, if I want to eliminate all my fractions at once, I need to think of a number that's divisible by both 2 and 3, and 6 would definitely work for that, so that's what I'm going to use. And I'm doing this without a calculator, so 6 divided by 3 is 2. 2 times 4 gets me negative 8. 6 divided by 3 is just 2. 6 divided by 3 is 2 times 16 is 32. Half of 6 is negative 3x. 6 divided by 2 is 3, times 3 is 9. 6 divided by 2 is 3, times 11 is 33. So I am going to encourage you to try to do this part mentally instead of stopping and picking up a calculator, because there's so much stuff going on here. It's really easy to lose where you were, and then you have to get back into the zone. It's easier if you don't take your eyes off your work and you're more focused. So I am going to encourage you to try that mental math. All right, and then we want our x's and our z's together. So we're going to add 3x to get negative 5x over here. We're going to subtract 9z and get negative 11z. And then we're going to subtract 32 and get 1. And then I'm also going to draw a box around this equation. So our next move is to go ahead and take these guys and pair them together. So I'm going to have to do negative 2x plus 7z equals negative 11. And pair that with negative 5x minus 11z. And that should equal 1. So this part, you can either do with substitution or elimination. Personally, I wouldn't go with substitution here because you're going to have to either move the x, remove the z over, divide everything. You're going to have to put fractions back into the equation. Personally, at this point, I would do elimination. I would just multiply the top row by negative 5 and the bottom row by positive 2. In doing so, I'm going to get rid of these x's. So I'm going to get looks like a 10x, a negative 35z, and a positive 55, and then I'm going to get a negative 10x, a negative 22z, and 2. And we're getting down to the nitty-gritty here. So negative 57z equals positive 57, hence z equals negative 1. And then you would just go back and find your x and your y. Since we already did that with this example using elimination, I don't think we need to go back and do it again. So what I'll do is I'll put an answer key just for these couple practice problems, and then you can just check and see if you got the idea.